All right, Jim Bollinger, NMH. Just want to talk about sinusoids today. As you know, I'm a big fan of repetition every day, talking a little bit more about the calculations we're studying. And I think over time, it gives a deeper understanding. And so today I want to delve into sinusoids a little more deeply. Before I begin, let's just talk a little bit about what you see here in front of you. 2 plus 2 and 4. I think they both indicate the same amount, but I think it's simpler to write 4. And my definition over the years of simplicity is fewer strokes of the pen. 1, 2, 3 strokes to write the number 4 on the left, 1 stroke to write the number 4 on the right. I'm going with the right-hand side. Now I'm talking about that right now because I realized that over the last 40 years or so of teaching, I've been saying something that really hasn't been all that right, all that correct. And I'm dating myself here, but I remember my mentor, one of my mentors at the school, a guy named Mike Datishev, wonderful math teacher. When I was talking to him about how to go about talking about a particular topic, and he said, tell him what it is, not what it isn't. I was making up a mnemonic device, and it really was ridiculous back in the day. And it was about logarithms. And he said, tell him what it is, not what it isn't. And I've been a firm believer of that ever since. And it's been very true that students pick up on something as to what it is, not what it isn't, better than little word devices. Okay? So where have I gone wrong in the past 40 years? So I've talked about, speed graphing sinusoids and, given a sinusoid, boopity, 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 boopity with a value here and a value there. It's in other videos I've done. And I said, well, that's a cosine function. Well, it's not. It's either a sine or a cosine function. And it really is, the simplest way to write this is using the cosine command. But I could have written it as sinusoid as well, or as a sine function as well. So I've got to take back my language a little bit, and that's what we're going to talk about today as to how we could have written sinusoids either way. Okay? So to do that, I'm going to harken back to my childhood watching the 3 major networks, and on one of them they did the whoa, 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 whoa. It was the 3 Stooges, and Mo would always do this, and then he'd poke Larry in the eye. So we're going to do a little sinusoid here. I think I'll start up here, and I'm going to go 2, 3. I'll stop there. All right, so if we looked at height as a function of time, the graph would look something like this. And that's a sinusoid, okay? And sinusoids are a 2-step function. And the first step is really all about taking a moment of time in this case and correlating it with a place on the circumference of the circle. Okay, and that's actually a linear function. Okay, so let's talk about that in more depth. We have 2 functions. We have the sine function and we have the cosine function. And if we start our walk, I'll make a little separation here because radian measurements are all about walking around the circumference of the circle. Right? All right, so I started my hand here, and I'll speed it up this time. And there's a pattern there. And how many times did I repeat that pattern? Actually 5. 1, 2, right? 3, 4, 5. And so what are we going to think about when we talk about the, well, that's 1 trip around the circle. That's going to match up to 1 trip around the circle, 1 cycle. And then, of course, we go around twice. Boom, 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 boom. Okay, that's the general gist. So this is no movement around the circle. And then when I go all the way around, I have traveled 2 pi units, or 6.28 radius lengths. I should have brought my lanyard. But if this is the radius of that circle, then it's about 1, 2, 3, 3.14, 4, 5, 6, 6.28 of these lengths. Now this circle looks a little bit bigger, but it's still going to be 6.28 of these lengths. I got to do it this way. 1, 2, 3, 0.14, 4, 5, 6, 6.28 of those lengths. That's what we mean by a unit circle, where the unit of measurement is the radius. Okay, now let's just take a look at a typical angle. There's a typical angle. Okay, a certain number of degrees. You're more familiar with degrees. But what if I extended that motion of that angle 360? Then isn't that an arc? I think in the sequential instruction, you look at arc length as a fractional part of a whole trip around the circle, right? So that angle can be measured in terms of, circumference. Where am I on the circumference? And that's what this discussion was about. So play it again if you want to hear it again. I think repetition is your friend. Okay, so let's keep this diagram on the board. 0. Well, what's the cosine of 0? Cosine of 0 is the width at this location because it has no height. It's 1. What's the sine of 0? Well, there is no height, right? So I could have done degrees. The cosine of 0 degrees is 1, and the sine of 0 degrees if I wanted to be in degree measurement. But I'm talking about circumference because it's easier to correlate data in the real world with the x-axis being distance and circumference. It matches up nicer, we don't want to, let's say a day 185, we might have the maximum temperature in a given year in this area, in the course of a year. What's that? On day 180 degrees, 185, 182.5 halfway through a year cycle, right? So we want to start working in radians. Now, I started the Mo-Larry-Curly experiment here with my hand at a maximum height. We'll use this one. Yeah, I can use this one right there. Okay. Well, that's not a maximum. What would a maximum be? Maximum height is here at pi over 2. So let's do that right now. Pi over 2 gets me a max of 1, right? We never get a bigger ratio in the sine or cosine curves, bigger than 1. All right, so I'm going to write this sinusoid. I'm going to write this sinusoid in terms of the sine function and the cosine function simultaneously because it's either one, right? I could write it either way. And let's see what it looks like when I do that. And then we'll choose, just like if you want to represent the number 4, you have a choice. You can represent 4 as 2 plus 2, or you can represent 4 as the number 4. Okay, I think we're going to choose whichever one of these has fewer strokes of the pen. Okay, but it'll be good to highlight the argument of the function. The argument of the function is what's in the parentheses. In other words, that part of the function that grounds us in this process, we're going to highlight in this video. Okay, so back to time, height as a function of time. The height of my hand height as a function of time. Okay, so we got to establish a few values. So why don't we say that I had been talking for 11 seconds before I started moving my hand up and down. Okay, 11 seconds. So here's the 11-second mark, and I'll just do it again, and somebody can count, will approximate. Oh, it's Three Stooges. I forget the theme song. I even forgot how many times I did that. Let's say that it took me 17 seconds to do that 5 times. 17 seconds. Okay, so we're going to start a little table of values here, where time and height as a function of time, at 11 seconds, my hand was, well, we got to figure out how, I'm about, let's see, I used to be 5'9", I'm shrinking. We'll see, I'm 5'8". 5'8", 5 times 12, 60 plus 8. Let's say I'm 68 inches. And I brought it down to chest level. Let's say that's 4 feet. Let's say that's 48 inches. And I said it took 17 seconds. So 17 plus 11 28. I got a lot of 8s in here. Whew. I don't know if I want so many 8s in here. Yeah, let's keep them. All right. So these are seconds. And these are inches. We might even put the unit measurements involved in this as subscripts. S for seconds and I for inches, something like that. And it might even help you to see the conversion process better. Okay. So remember, this is a lecture. I wouldn't be talking this long in class, but you can watch this for homework. All right, here we go. What I used to say was it's a cosine function. Okay, so let's do it as a cosine function. So there's 1 revolution. The hand goes down and up. So that's 1 revolution to there. So that's 1, 2, 3, 4. Oh boy, I got to shift this over because I don't have enough. So we're back here now. So this is 1168. 1168. And I go 1 revolution, 2 revolutions, 3, 4, 5, right to there. And I came back to that, huh? Okay, so I came back to that. This is not what I wanted to show, but that's okay. We'll write that up the way we're dealing with it right now. So we came back in 17 seconds. We had 28 to 48. 28 seconds, 48 inches high. I usually like to do something here. All right, so what's this function? This function has to be measured from the middle. In the middle, we know that our baseline goes up to 48 and down to 28. So it looks like 38 is in the middle. I'm sorry, 48 to 68. I really botched that with so many 8s in here. So this is a height of 68. Should have correct me, but you can't because it's on a computer. This is 48. There we go. The old man's got it now. So there's 58. All right, that's the middle. So that's what we start with, 58. The amplification is 10. Hopefully we've been doing enough of these in class that this is familiar. It's a cosine function. And we have 5 revolutions, which is 10 pi. And that occurred in what, 17 seconds? And we started this analysis. I guess I got to move this so it's not in the way. So we started this analysis at a time of 11 seconds. So why don't I put t minus 11? There's our function. Okay, and we practiced that in class. So hopefully that makes sense at this stage. 10 pi, right? 5 times 2 pi. There's our revolutions, okay? So this is really a linear function here, right? I mean, when you write the equation of a line, this is what an equation of a line looks like. If I said, write the equation of a line, 1168, 28 to 48, I think you would say something different, but we are creating a 11 equals 0, 28 equals 10 pi. All right, I mean, that's what you're looking at. Okay, so let's write it as a sine function. As a sine function, not much changes, except that our table of values, we want 11 to match up with pi over 2. And we want 28 to be 5 revolutions, which is 10 pi plus pi over 2, right? Which is 21 pi over 2. And we'll work with these numbers, plug them in to show you how it works in a minute. Hopefully you can see that if I turn it down. Yeah, so I probably should repeat this because I did not have this in a good position. But we want 11 to be pi over 2. Why do we want pi over 2? Because the sine of pi over 2 is 1, which is a max. And that's where we're at. We're at a max. So we want 11 seconds to match up with pi over 2. This doesn't change. 58 is still the center. We're still going up and down 10, except we're fine. Okay, so it's at pi over 2, we start to drop. So we've got the sine function, and we want still the same thing. We still want 5 revolutions, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, 9 pi, 10 pi. We've done that in class, right? And that's the same. That's at 10 pi over what, 17, right? But we're starting where now? T minus pi over 2. Okay, now all the strokes are the same of the pen here, except t minus 11, excuse me, I'm getting ahead of myself. I got very little room here. So I botched that. T minus 11 plus pi over 2. My forgiveness. And then I got to get a bracket here or something to show that. The whole purpose of the video was to do that, and I lost track of what I was saying. Okay, but we're back on track now. That's why repetition is my friend, because then the next time I do it, I'm less likely, right? This is the second time I think I've talked about this. I talked about it in the Algebra 2 class last term, and I think in a pre-calculus topics and trick. I think we talked about it once, because it's harder to write this way than that way. But they're both sinusoids. They're both the same graph. So let's put in 28 here. Put in 28, just to show it work. 28 seconds. All right, 28 seconds minus 11 seconds is 17 seconds. 17 seconds divided by 17 seconds cancels completely. Seconds into seconds equals 1. All right, so we now know we don't have any units of measurement whatsoever in this problem. We have generic numbers. And now I'm going to take the sine of 10 pi plus pi over 2. Well, 10 pi is right here. Adding pi over 2 takes me there. And what is the sine at pi over 2? 1. And 1 times 10 is 10, plus 58 is 68. Okay? And I guess I was over here. I put in 28. Sorry. Both are 68. Okay? Both are 68. So I wish I didn't flub up this in the video, but corrected it. And that's half of math, is knowing when you make a mistake. Right? That's why you always want to do things from 2 perspectives. Now, if you do it 2 different ways and get the same answer, you're likely right in most situations. Okay? So that's just a little deeper grasp of writing sinusoid. So I'm no longer going to say this is a cosine function, because that's what made me do this video, right? That's what made me record this. Okay, when I got up this morning, I went, wait a minute, I've been saying something that's a little off. Okay, but I don't think I'm alone. I think most people would say, oh, this is a cosine function. Why? It's a little easier to write. Okay, but I could have written it as a sine function as well. And so I did. Okay, so that's just something to think about, and I'll publish this, and hopefully it might help someone. All right, be good. Oh, over here. I haven't had my first coffee. This is trouble.